Hi students, how are you? I hope that you are doing fine. So in our last class we have discussed few important questions. Today we will do some more questions as far as these real numbers are concerned. If you can do these questions, I am sure that you will get 100% marks in real numbers. So let us do the first question. Find the largest number which divides 615 and 963, leaving remainder 6 in each cases. So we have to find out the largest number. That means we have to find out the SCF. So we have a remainder 6 in both the cases. So we will subtract. So it will be 609. So it will be 957. So we have to find out the SCF of these two numbers. So 609, let us do the prime factorization. Can we do it with the 2? Not possible because it is an odd number. Let us do it with the 3. First of all, check it whether it is divisible by 3. So 6 plus 9 is 15. 15 is divisible by 3. Therefore, it is divisible by 3. So it will be 203. So 203 is not divisible by 3. So next 5 is not possible. Let us take 7. 7 will be 2, 14, 6, 9. So 609 can be written as 3 into 7 into 29. Now we have to do 957. In the case of 957, let us check it with the 3. 12, 9, okay, this is divisible by 3. So 3, 1, 9, 319, 11. So it will be 29. So we can write 957 as 3 into 11 into 29. Now you can see there are two things, 3 is common and 29 is common. So the SCF is the smallest power which is common in both the cases. So 3 into 29, that is 87. So the SCF of these numbers will be 87. Now let us do question number 22. It says that if A is equal to 2 cube into 3, B is equal to 2 into 3, C is equal to 3 to the power n and 5, and the LCM of these three numbers A, B and C is 2 to the power cube into 3 square into 5, then we have to find the value of n. Now we know that the LCM will be the greatest power in all three cases. So the LCM of these numbers, the LCM will be, as far as 2 is concerned, we have 2 to the power 3. As far as 3 is concerned, 3 to the power n and 5 to the power 1. And the LCM is already given to us. What is this? LCM is 2 to the power 3, 3 to the power 2 and 5. Now both are equal, isn't it? LCM is given to us and we found out one LCM. Now equate the powers, the exponents. Now 2 to the power 3, 2 to the power 3 is there. Now 3 to the power n, here 3 to the power 2. Therefore 3 to the power n is equal to 3 to the power 2. Therefore n is equal to 2. Let us do question number 23. It says, find the smallest number by which root 8 should be multiplied to get a rational number. Now root 8, we have to multiply it with the smallest number so that we get a rational number. So root 8 can be written as 2 into 2 into 2, 2 into 2 into 2. So we can take out this, we can take it 1, 2 outside. Here if we multiply it with another 2, then we can take 2 outside, then that will be a rational number. So if we multiply it with the 2 into 2 into 2 into with another 2, so we will get 16, root 16. Root 16 we know that 4. So if we multiply with the root 2, the smallest number, if we multiply root 8 with the root 2, we will get root 16 and then we will get 4. So that will be the perfect square. Now let us do question number 24. It says that if 504 is equal to 2 to the power m, 3 to the power n into 7 to the power p, then find the value of m minus n plus p. Now we have to do the prime factorization of 504. So 504, it is an even number, it is divisible by 2, so it will be 252. Again 2, 1, 2, 6, again 2, 63. Now it is not divisible by 2, let us take 3, 21, again 3, 7. So 504 can be written as 2 to the power 3, 3 to the power 2 into 7. So that is equal to 2 to the power m into 3 to the power n into 7 to the power m. Now you see the base and the exponents. Now equate. So we get m is equal to 3, n is equal to 2 and p is equal to 1. So we have to find the value of m minus n plus p, that is 3 minus 2 plus 1. So it will be 4 minus 2, that is 2. Now let us do question number 25. We have to find out the smallest number which is divisible by both 306 and 657. So we have to do the prime factorization of 302, that is 1, 5, 3. So it is 9, so another 3, 51. So 3, 7. So 306 can be written as 2 into 3 square into 17. And the next number is 657. 657. So is it divisible by 2? No. 3, 12, 18. Okay, 3 is divisible. So 2, 1, 9. 2, 1, 9. Again 3, 73. 73 we know that it is a prime number. So 657 can be written as 3 square into 219. Therefore the LCM of 306 and 657 will be the greatest powers. So the greater 2, as far as 2 is concerned, there is only 1, 2, 3 is concerned, there are 3 square, and 17 and 219, 2338. Next question is question number 26. We have to find out the SCF of these two numbers. So SCF, we know that the smallest power common in both the cases. So as far as P is concerned, only P square, and Q is concerned only Q. So the SCF is P squared Q. Now let us do question number 27. Find the least number that is divisible by first 5 even numbers. We know the first 5 even number is 2, 4, 6, 8 and 10. So we have to find out the prime factorization, that is 4 is equal to 2 into 2, 6 is equal to 2 into 3, 8 is equal to 2 into 2 into 2 and 10 is equal to 2 into 5. The LCM of these 5 numbers. So the LCM we know that the greatest power. So the greatest power as far as 2 is concerned, here we have a 2 cube. So it will be 2 cube, and 3 there is only 1 3 and 1 5. So it will be 8 into 3 into 5, that is 120. Question number 28 is a tricky question. It comes in MCQ. The total number of factors of a prime number. Now we know that the prime number has only 2 factors, the number itself and 1. Therefore the total number of factors of a prime number is 2. Now let us do question number 29. The sum of exponents of prime factors in the prime factorization of 196. So first of all, let us do the prime factorization of 196. So it is 2, 9, 8, another 2, 49. So 49 is not divisible by 3, so it will be divisible by 7. So 196 can be written as 2 square into 7 square. Now we have to find out the sum of the exponents. Sum of the exponents is 2 and 2. So sum will be 2 plus 2, that is 4. Question number 30. The exponent of 2 in the prime factorization of 144. So first of all 144, let us do the prime factorization, that is 72, 236, 218, 29, so 3. So 144 can be written as 2 to the power 4, 1, 2, 3, 4, 2 to the power 4 and 3 to the power 2. So the exponent of 2 is 4. So the answer is 4. Question number 33, 2 plus root 5 divided by 3. So it is an irrational number because root 5 is there. So it is an irrational number. Now you see question number 34. The decimal form of 129 divided by 2 square, 5 to the power 7 and 7 to the power 5. So it is clearly evident that 7 to the power 5 is there. So it will be non-terminating, non-repeating. Now question number 35. Is the product of a rational number and irrational number. So let us take the product of a rational number and an irrational number. Root 2 is a rational number and 3 a rational number. The product of these 2 will be 3 root 2. 3 root 2 is again an irrational number. So the product of a irrational number and a rational number will be an irrational number. We have seen the product of a rational number and an irrational number. So what will happen if we add a rational number and an irrational number? So let us take same example 3 and root 2. If we add this, it will be 3 plus root 2. 3 plus root 2, we know that it is an irrational number. So question number 37. The product of two different irrational numbers is always. Now let us take the example of root 2 and root 8. So these are two different irrational numbers, both are irrational numbers. Now if we multiply this, we will get root 16, root 16 is 4. Now if we multiply root 2 with root 3, we will get root 6, which is an irrational number. So when we multiply two different irrational numbers, we can get a rational number and we may get an irrational number. So the answer will be, it can be a rational number and it can be an irrational number. So option 3, both of the above is correct. Now let us do question number 38. If b is equal to 3, then any integer can be expressed. We have studied in our previous classes that any number can be expressed in 3q, 3q plus 1 and 3q plus 2 if b is equal to 2, and if b is equal to 2, it will be 2q and 2q plus 1, and if it is b is equal to 4, it will be 4q, 4q plus 1, 4q plus 2, 4q plus 3. So the answer is 3q, 3q plus 1, 3q plus 2. Now let us do question number 39. The product of 3 consecutive positive is divisible by 4, 6, no common factor, or only 1. Now let us take the examples of 1, 2 and 3. So this will be 6, 2, 3 and 4, 6, 24, 3, 4 and 5, 60, 4, 5 and 6, 120. If you see these answers, everything is divisible by 6. 6 by 6 is 1, 6 by 4 is, this is 4, this is 10, this is 20. So you can clearly see from here, if the product of 3 consecutive positive numbers is clearly divisible by 6. Let us do question number 40, that is the whole numbers. Whole numbers, we know that it starts from 1, 2, 3, 4, 5, etc. And natural numbers, this is whole numbers. Natural numbers starts from 1, 2, 3. I told you that these are the counting numbers. So natural numbers starts from 1, 2, 3. Whole numbers 0 is also included. So the answer is 0, 1, 2, 3, 4, 5. Now question number 41. For some integer p, every even integer can be in the form. So we have seen that all even integers are divisible by 2. So all even integers can be expressed in the form of 2p because all even integers are divisible by 2. So the answer is 2p. Now let us see question number 42. What about odd numbers? So 2p plus 1. All odd numbers can be expressed in 2p plus 1 and even numbers can be expressed in the form 2p. Let us do question number 43. The product of two consecutive natural numbers is always, options are prime number, even number, odd number, even or odd. So let us take the examples. Two consecutive natural numbers. So we know that the natural number starts from 1, 2. So two consecutive natural numbers. 2 into 3, 6, 3 into 4, 12, 4 into 5 is 20. In all these cases, the answers are even numbers. So you can see it from here. If we multiply two consecutive natural numbers, 1 and 2, 2 and 3, 3 and 4, 4 and 5, we will always get an even number. So we have done so many important questions from this chapter. I am sure if you can do this, you will get 100% marks from real numbers. Wish you all the best.